Continuing with section 5.1, we saw what a unit circle is, and then we found some points on the unit circle given some information, and also we checked whether a given point lies on the unit circle or not. Now the next thing we have to learn here is what are terminal points and what are some values to which, or some values to which these points are related. Okay. So let t be a positive real number. So starting with so a unit circle, right? On the x-axis, where is the unit circle crossing the x-axis? It crosses at x is equal to 1. What is the y-coordinate there? Y-coordinate at that point is 0. So here, this is what I have here, right here, this point. So the coordinates are 1, 0. Okay, here are the coordinates. So if you move on the circle in the counterclockwise direction, so you can keep moving forever, right? But if you stop somewhere, so you have traveled some distance. You have traveled some distance starting from the point 1, 0. You arrived, let's say, and you stopped here at the point xy, at the point P, which has the coordinates xy. Then this is the terminal point. For the value t, whatever the value is, but it will be a positive value. If in other way you travel, we always start from 1, 0, okay, from the positive x-axis. So we always start here, but now we go in the negative direction. So now t will have a negative value. So we go in this direction. Wherever you stop, that will be the coordinates of that point on this unit circle will be the terminal point for that value of t. Okay. So how do we get those values of t? How do we measure those values of t? Well, on a circle, how will you measure the length, or how will you measure the distance on a circle? On a circle, so let's say you have a ring, you have like a bangle or something, or a ring. How will you measure the length, or how will you measure what is the length from, let's say, this point to this point? It doesn't look like half of the circumference, but even for the circumference, you need to know the radius. So if we don't know the radius and we want to measure what is the length of this piece, how would you do that? Well, one way of doing it is that you put your ring, on the floor or on a smooth surface, straight surface, and then you take a thread and put the thread alongside this circle, and the distance that you have to measure, if you take an ink and mark the thread in those 2 points, and then straighten it, measure it alongside a ruler. So another way to think about this is that you have a circle, unit circle, and now you take a real number line with positive numbers on one side, negative numbers on other side. Now when we have, and this, we are taking the number line in the vertical direction. So in the vertical direction, remember that the y-axis, the positive values are above 0 and the negative values are below 0. So here this is our 0. Positive values, I draw in the positive direction, I draw it with the pink color, and the negative I have it with the green color. So bring this number line close to the starting point of the unit circle, close over here. So bring the line over here. That's what I did in the next picture. And then we start wrapping this line on the circle. So you see that when we walk on a line, so for example, if someone starts walking here and walks on this line to upward, they will never come back to a point twice. Okay, they will never travel a point twice, or pass by a point twice, or more than twice, if they keep on going on and on. If they return, yes, we will pass through the points again. But if one keeps going on and on forever, then they will never return to the same point. In the same way, if someone goes in the negative direction, they will never travel through a point more than once. But this is what happens on the circle. So if you take this, match the 0 of the line with the 0 of with the starting point of the circle, unit circle. So 0 is over here. Both zeros, the 0 of the number line and the 0 of the unit circle. Now the positive numbers, so think of it as like a flexible kind of a line. So wrap it around the circle in this direction with the positive number line. So you keep wrapping. Can you see we are traveling through, which means the person is traveling, and then they are traveling through same point many times. Okay? And in the same way, we wrap the negative side of the axis from the other side. So the wrap around of the positive side was in the counterclockwise direction, right? Because we wrapped it in this direction. Now we will wrap with the green side, which is the negative side, in the clockwise direction. So if again you wrap, so over and over and over, forever, infinitely many times. So all the numbers of the line, can you imagine? All the numbers of the line, there are infinitely many, they are on that circle, on that unit circle. Strange, right? It looks like the circle is bounded, it finishes, it stops, so it should have limited number of points compared to a line which goes on and on and on forever. But that's not the case. All the points of the line, they fit on the circle, they lie on the circle. Okay, so now, so for example, where will be 1, positive 1, positive 2, positive 3? Let's see, where will they be? And then similarly, negative 1, negative 2, negative 3. So let me show you where they will be in first circle. So, oops, just bear with me. Removing extra things from here and just showing you. So if you notice, this is the radius. This is the radius, and so this length is 1. Imagine a length of this size on the curve. So starting from here, looks like somewhere here, this piece, it looks more than 1 to me now. So somewhere here, maybe this looks smaller, but roughly somewhere here will be this length. When you straighten it and put it on this one, they should fit. So t is equal to 1 will be the point here. What about t is equal to 2? So same as this length, we go from this point. So somewhere here will be 2, the value 2, and then somewhere here will be the value 3, somewhere here will be the value 4, and so on. Okay, so somewhere here will be 5, and so here will be 6, and then 7, and then 8, and then so this is what we mean by the values of t. So if someone has traveled 2 units, so then they have arrived this point. If they travel 3 units, then they will be arriving at this point, and so on. Okay, so in the counterclockwise direction, the distance is going to be positive, and by distance here we mean t, not x. Okay, we are not taking x because x is the horizontal distance, y is taken for the vertical distance. This is the distance on the circle, so we have to use another variable. So we are using t. Okay, if you understand this, then we can move on and try to find the terminal points of some special numbers, some special t values of t. Okay, first understand. Okay, again, this is a note. I have mentioned this before, but again, reminder that on the unit circle, counterclockwise motion is considered positive and clockwise motion is considered negative. A distance of 0 starts us at the point 1, 0. So the point here on the x-axis, this point, this has coordinate 1, 0. So this is our starting point always. And if we go in the counterclockwise direction, we are traveling in the positive direction. So the value for t will be positive. And if we go in the clockwise direction, means like it's shown in this second circle, then will have a negative direction. Okay, we now look for terminal points of pi, t, value of t, pi over 2, 3 pi over 2, and 2 pi. You might be like, but what are those? And remember, these are real numbers. Pi, 2 pi, any multiple of pi, these are real but irrational numbers. Okay, because pi is irrational, so any multiple of pi will be irrational. But it's very easy to figure out the terminal points of these points, or these real numbers, these values of t. So how do we do that? Again, let's look at this circle. It's okay. Just assume this is the center is over here, and this is 1, this is 1, this is 1, this is 1, and this should be 1. Okay, all these lengths are 1, 1, 1. So if I draw any line from here to the circle, that will be 1. Length of that will be 1. Okay, so now let's put the put the points which are so I'm going to put the points where the circle is crossing the axis. So what are the coordinates of this point? 1, 0. What about this one? 0, 1. What about this one? This will be -1, 0. And then this one will be 0, -1. Okay, so if you recall now, if I start at the starting point, which is that one, and if I go through the whole circle, so I move along the positive direction, come back to my starting point, then how much distance have I traveled? Can someone guess it? So we have traveled, the length traveled is the circumference of the circle. So what is the circumference of this circle? Well, the formula for the circumference is 2 pi r. But in our case, r is 1. So we have 2 pi. So we have traveled a distance of 2 pi. So if you want to see what is the terminal point for 2 pi, so you will say 1, 0. Okay? Because in order to travel a distance of 2 pi, you have to start here and then you come back to this point. Now what about half the distance? So if I travel half the distance, so then I have traveled how much? I have traveled pi, right? Because it's 2 pi, half of 2 pi is pi. So if you travel half the distance in the positive direction, so you start here and you will travel this much. So what is the terminal point? -1, 0. So the terminal point for pi, so at this point, t will be equal to pi. Okay, so we saw what the terminal point for 2 pi, we saw what the terminal point pi is. Now what about pi over 2? Well, pi over 2 is half of pi, which means quarter circle. So now go back and look at the starting point, and from the starting point travel quarter circle. So where will you be? So you are starting here and you are going along the circle and you arrive here. So what is the terminal point? 0, 1. What about 3 pi over 2? So it means 3 quarters. So it means we start at the starting point, we cover this quarter, then this quarter, and then this quarter. So we have covered 3 quarters. So we have t is equal to, so over here t will be equal to 3 pi over 2. So 3 pi over 2 is 3 quarters. So the terminal point is 0, -1. What if we travel in the counterclockwise? So now we know the terminal points of all these values of t. So this has been described here. The figures that I was making, all of them are here. So we should be able to see that. Okay, now we will be trying to find the terminal points of some given t values. I would suggest that you draw a unit circle and try to see where you are landed. So for example, the first one, t is equal to negative pi. Negative pi means, well, always remember starting at here. Maybe first you should write the coordinates of each point. So each intersecting point, like this one will be 1 0, this will be 0 1, this point is negative 1 0, and this one is 0 negative 1. Now starting at the starting point, we go in the negative direction and we cover how much distance? Pi units. What is pi? Pi is half of 2 pi. It means we are traveling half the circle. So we are going from here to here. So the terminal point of pi, negative pi, is negative 1 0. So t point is negative 1 0. So t point for t is equal to negative pi. Now notice here, for t is equal to pi, we had the same terminal point. Next is negative 3 pi over 2. So it means we are starting here and we are going 3/4 of the circle in the clockwise direction, which means negative direction. So negative 3 pi over 2. So this is negative 3 pi over 2. But remember, this was pi over 2 as well. That's what I said, that when points overlap, many points on our number line overlap in the circle. So what is the t? So these are the t values. This is the t value now. And what is the terminal point? So t point or terminal point is 0 1. Okay, next one is t is equal to negative 3 pi. Negative 3 pi. So what does that mean? It means start here, move in the negative direction. How much? 3 pi's. So we go 1 pi, we arrive here. Let me say, we are starting at A, we arrived at B. This is 1 pi. Now I keep going from B to A. This will be 2 pi's. And then I go again. I am drawing this line a little bit away from the circle just to show you the motion. But it should be on the circle. It shouldn't be greater than the circle. Okay. So this way, again, we reach at B. That is, we have traveled negative 3 pi. So what is the point? Negative 1 0. So the terminal point for t is equal to negative 3 pi is negative 1 0. And if someone asks you to go 3 pi, then you have to just go in the other direction. So you will be going, this is your circle, start here 1 2 3. So you see 3 pi also have the same terminal point, which is not a big deal. Okay, there you will see many same terminal point, or a point is a terminal point for many t values of t. So this is how we look for the terminal points. Okay, now we are going to focus on some special values of t and try to see how we can figure out the terminal points of those. Now previously we have seen the terminal points of, for example, t is equal to 0. So what was the terminal point for that? 1, 0. Where t is equal to pi over 2, we have 0, 1. T is equal to pi, we have -1, 0. T is equal to 3 pi over 2, we have 0, -1. And then we can have 2 pi, so which is the same as this. So I can say 2 pi, it will be here. And so on. Now we are going to look at pi over 6, pi over 4 and pi over 3. These are the three major very important t values which we will encounter often later on. So we will start with the t is equal to pi over 4, and because we have to find the terminal point, so we just choose, say, let xy be the terminal point, and then we try to figure out what is x and what is y in there. So and we make some other observation from geometry. So let's see. So where will be pi over 4 first thing? So again, if this is the circle, then this is 0. Over here the t will be pi over 2. So where will be pi over 4? Well, pi over 4 will be half of pi over 2. So it means it will be somewhere here. Just like a point which divides this length from 0 to pi over 2, that piece into half, 2 pieces. Okay, so it halves the, so this is where the pi over 4 is, where t is equal to pi over 4. But what are the coordinates of the point? That's what we want to figure out. So note here, this point of course lies on the x, on the unit circle, so it means it satisfies the condition, the equation of the unit circle. So let, okay, so I think I have already mentioned here, yeah. Note that P is equidistant from the points 1, 0 and 0, 1 along the unit circle. It's the same thing that I just said, that the point x, y, it divides the length from 0 to pi over 2 into half. So this is x, y. So it lies on the unit circle, so it satisfies the equation, but also it lies on the line y is equal to x. Why do we know that? Well, because this is passing through, the point is in the, it is dividing basically the first quadrant into 2 equal portions. So what line does that? The line y is equal to x. So the point lies on the line y is equal to x, as well as it lies on the unit circle. So we have two equations, x square plus y square is equal to 1 and y is equal to x. So we just do our substitution and get the value for one of the coordinate x or y, and then find the second coordinate. So since y is equal to x, I am going to replace the y in there by x. So sometimes it's kind of convenient and it's understandable if you give the equations numbers. So that is the equation 1 and this is equation 2, and then I will say from equation plug in. Okay, so I will say plugging equation 2 in equation 1. What does that mean? It means from equation 2 I can see that we have y is equal to x. So I'm going to plug this in equation 1. So what do we get? X square plus x square is equal to 1 because y is x. So this gives me 2x square is equal to 1, which gives me x square is equal to 1 over 2, which then gives x is equal to plus minus square root of 1 over 2 or plus minus 1 over square root of 2 because square root of 1 is 1. Okay, now what value will I take? There are two values, plus or minus. Which one will we take? Well, because we are in the first quadrant, so we'll take the positive value. Okay, so discard the negative value. X is equal to 1 over square root of 2. Again, now this is the value of x, we got it, but we would like to rationalize it. Means we want to get rid of the square root from the denominator. So what do? We multiply by the by itself, right? By the square root of 2 top and bottom. So it will give me, on the top I get square root of 2, at the bottom I get 2. So this is the value of x. Now we can say from equation 2 y is equal to x, so y is equal to square root of 2 over 2. Therefore the terminal point for t is equal to pi over 4 is square root of 2 over 2 comma square root of 2 over 2. So this is how you can figure out the terminal point for pi over 4. Now you do not have to do this anywhere. You will not be asked to figure out or find out. You should know that. You should memorize it. You should know that the terminal point for t is equal to pi over 4 is square root of 2 over 2 comma square root of 2 over 2. That is your responsibility. Okay, that's enough for this video. The rest in the next video.